So today we're reviewing how to find the area of some basic shapes, specifically rectangles, parallelograms, triangles, and circles. Okay, so you can think of area as the amount of squares that will fit inside of a shape. All right, so that's why all of my examples today will be on grids. So that way you can really see the squares inside of it, because that's basically what we're trying to find. So for example, for the rectangle, what I really want to do is find the area of this rectangle. What I'm trying to do is find how many squares are inside of it. And rectangles are kind of easy because you could count 1, 2, 3, 4, 5, 6, 7, 8, 9. You could just count them up. But there's a faster way to find out how many squares are in here. It's the number of squares sideways times the number of squares vertically. Or in other words, the length of the rectangle times the width of the rectangle. Okay? So the length of this rectangle is 1, 2, 3, 4, 5, 6, 7, because 7 squares would fit along the side. And then the width of this rectangle is 1, 2, 3, 4, because 4 squares would fit along this side. And so if I just do 7 times 4, I'll have the area. And 7 times 4 is 28. So in this case, I don't have units labeled on here, so I'll call them square units. I'll just call the units units. All right, so there's 28 squares in here. So the area of this rectangle is 28. And you could count them up, or the faster way is 4 rows of 7. Okay, now the next 2 areas are all based off of the rectangle. So the next one is parallelogram. Now in a parallelogram, opposite sides are parallel. See how the top and bottom, they run alongside each other, they're parallel. And the sides, they run parallel to each other. And the formula for the area of a parallelogram is base times height. Okay? Now, the base of a parallelogram is one of the sides. For example, this side. I'll just use the bottom. 1, 2, 3, 4, 5, 6. And the height of the parallelogram goes from its opposite side straight down to the base. So the opposite side of this is up here, and I'll just pick a spot up here, and I'll go straight down to this base. And I'll form like a little right angle to it. So imagine going straight down from it, and my height is 1, 2, 3, 4. Okay? So the area of this parallelogram is simply 6 times 4, which is 24 square units. Okay? And the reason why this formula works is because a parallelogram is basically a rectangle that's been rearranged. I'll show you what I mean. Imagine cutting off this little triangle right here and then just putting it right here. If you notice, we then have a rectangle, and its length of the rectangle is 6 and the height is 4, which is exactly what we use to find the area of the parallelogram. Okay? So a parallelogram, just a slightly rearranged rectangle. Okay? But you have to remember that that height is from the top to the bottom straight down. It's not along the diagonal. That diagonal line is not the height. Okay. So let's do the next one then. The next one is a triangle. And I've got 2 examples because triangles tend to trip up people. Okay? The area of a triangle is base times height and then divided by 2. Okay? The reason why this formula works is a triangle is basically half of a parallelogram. And I'll show you why in a little bit. Okay? But let's find this area. Okay. So the base of a triangle is one of the sides, and pick the easiest side as your base. For this one right here, I'm using the bottom. 1, 2, 3, 4, 5, 6. So my base is 6. Okay? Now, just like in a parallelogram, the height goes opposite of the base. So for a triangle, we go to the corner opposite of the base. So that would be up here. And then you go straight down to the base, and that'll be your height. And again, it should form a little right angle there. Okay? 1, 2, 3, 4, 5 is my height. So the area of this triangle is 6 times 5 divided by 2. base times height divided by 2. 6 times 5 is 30, divided by 2 is 15, so this is 15 square units. Okay? Now, I explained to you that a triangle's formula works like this because it's half of a parallelogram. And here's how we know that. Imagine taking this triangle here and just repeating it on top of itself. Okay? So let's say I took this triangle, flipped it upside down. So this side, I stuck it right along this corner right here. So it's 6 here, 2, 4, 6 here. And then I took this side and ran it down here. All right. So you got this triangle and they're put together again. Notice, it's just a parallelogram. And we know the parallelogram formula is base times height. So if we cut that in half, the area of the triangle is base times height divided by 2. Okay, so most of these shapes, their area formulas are kind of related. Okay, I've got one more triangle because these are the triangles that tend to trip up a lot of people. Okay, it's still going to follow the same formula, base times height divided by 2, but this one's a little trickier, and I'll show you why. All right, I'm going to use the easy side as my base. In this case, again, it's on the bottom. And by the way, the base doesn't always have to be on the bottom. Okay, it could be on the side, it could be turned sideways, but I always use the side that's lined up with the grid because it's easier to count. All right, so 1, 2, 3, 4 is my base. Now, this is where it's tricky. To find the height, I take the corner opposite of the base, which in this case is up here. Okay, but to find the height, I have to go straight down to the base and be perpendicular to the base. So if I drop the height straight down from here to the base, notice it ends up way out here. And that's okay. It's okay for your height to end up past your base as long as it's perpendicular to it. See how it forms a right angle here? All right, so my height is 1, 2, 3, 4, 5, 6. So my height is 6, okay? So if I want my area of this triangle, I'll do base, here I'll do it up here, 4 times height, 6, divided by 2. 4 times 6 is 24, divided by 2 is 12. So this is 12 square units, okay? So again, when you find your base and then locate your height based off of it, it's okay for the height to stick out past that triangle, okay? The important thing is that it runs straight down and it forms a right angle to where the base would be. You could, even if it helps a little bit, you could just extend this base line out here so you can know for sure. But that would be your height right there. Okay? All right, last one. And this one's a little different than the other ones because this one is a circle. Okay, so the circle formula is not actually related to the previous ones. The circle formula is pi times the radius squared. Okay? Now, if you can't remember what the radius is, in a circle, the radius goes from the center to the edge. Okay? So in this case, this circle here, my radius is 1, 2, 3. So, that's the only dimension I need to know in order to find the area of a circle. So, the area of the circle for this one would be pi times 3 squared. And you can give your answer in a couple of different ways. I'll show you 2 different ways. One way is you can leave the pi symbol in it. 3 squared is 9. And 9 times pi, you could give your answer as 9 pi units squared. Okay? And that's called the exact form. It's in terms of pi. We're not rounding it. We're not using decimal approximations. We're using exactly that answer. Okay? But if you're a person who wants an approximate answer because you want a number that's a little bit easier to work with, what you can do is on your calculator, you can just do 9 times pi on your calculator and see what it comes out to. And 9 times pi comes out to about, let's say, 28.3. 28.3 units squared. All right? And that's called an approximate answer because we put in pi and then we rounded the decimal place, okay? So depending on what you're working with, you might be asked to give your answer in exact form, or you might be asked to round it. Either way, that's how you'd find the area of the circle, okay? So, hopefully you found this video helpful. If you did, please hit that like button. Also subscribe because it really helps us out. But with that being said, good luck on your math, and I will see you next time.